Imagine a city inside your body, home to trillions of tiny residents, each one working to influence your health. Although this might sound like the beginning of a science fiction novel, it's actually just your gut microbiome. This community of microbes play a powerful role in shaping your immune system, regulating inflammation, and even determining your risk for chronic disease. One of the most powerful influences on this microbial world is your diet. With that in mind, what if the path to better health doesn't start in the pharmacy, but in the gut? By decoding the complex relationship between diet, gut microbes, and disease, we may move closer to a future where personalized nutrition becomes a powerful tool in preventing and managing diseases. Before we explore how these three factors can transform medicine, we need to look at three key connections: the microbiome disease connection, microbiome diet connection, and diet disease connection. To begin, the gut microbiome plays a key role in maintaining physical and mental health. When the microbial community becomes imbalanced, a state known as dysbiosis, it can trigger a cascade of health problems all over the body. For example, a decrease in bacterial diversity of your gut has been shown to be a risk factor for inflammatory bowel disease. In addition to digestive diseases, gut dysbiosis can also cause behavioral disorders, as the bacteria in your digestive system have recently been found to be an important mediator of signaling between the gastrointestinal tract and the nervous system. This growing body of evidence underscores the influence of gut microbes not only on digestion, but across multiple systems, further highlighting the microbiome as a central player in both physical and mental health. Moving on to the diet microbiome connection, our diet is one of the most powerful tools for shaping the gut microbiome. For example, dietary fibers are fermented by gut bacteria, which play a crucial role in reducing chronic inflammation. While much of the research regarding the gut microbiome in food discusses how fibers are beneficial, another food group plays a large role in the gut microbiome: amino acids, which are the building block of proteins. More recent research has shown that some amino acids may act as a prebiotic, which help grow beneficial bacteria in the gut. For example, tryptophan, which is found in foods like turkey, dairy, and seeds, can be metabolized by gut bacteria into products that influence both gut health and brain function. On the other hand, however, the amino acids found in fatty animal products have been found to increase inflammation and cardiovascular risk. Overall, what we consume affects our gut microbiome in a very clear yet complex nonlinear way. Lastly, diet has long been associated with health outcomes, but we now know that much of the influence is mediated through the microbiome. For example, diets high in fiber have been linked to the risk of type 2 diabetes and heart disease, not just because of their nutrient content, but because they support beneficial bacteria that produces anti-inflammatory compounds. By understanding how specific food groups influence gut bacteria, which in turn influences health, doctors and scientists can develop treatments that modify the microbiome to restore balance and promote wellness. For example, probiotic supplements and tailored diets can correct microbial defects. These treatments work by enhancing beneficial microbes, suppressing harmful ones, and supporting the body's natural immune responses. Through this, we can move beyond a traditional one size fits all treatment and shift towards therapies that target the root cause of disease, improving both prevention and long term health outcomes. Additionally, these treatments can revolutionize the accessibility of medical treatments, as they're often more affordable and less invasive than expensive procedures or medications. By harnessing the power of the microbiome, we have the opportunity to transform the way we treat disease, ultimately reshaping the future of medicine.